Today we have with us John Durkos from Road Systems Incorporated, headquartered in Big Spring, Texas, but working from offices in Cleveland, Ohio. John has been Vice President Technical Support for Road Systems for 21 years and has 37 years experience in providing technical support and product promotion in the highway and roadside safety industry, specifically with barriers, end terminals, and crash cushions. Mr. Durkos has served on several NCHRP panels and has been an active member of ATSA, TRB Committee, AFB 20, the Committee on Roadside Safety Design, and Task Force 13 for over 30 years. Please welcome John Durkos.
Thank you, Eric, and good morning, everybody. I'd like to send a special welcome to folks at the South Carolina DOT and welcome to this morning's webinar. And I'd also like to send a personal thank you to Henry Cross, who was very instrumental in helping to get this set up. So, Henry, I'm sure you're out there. Thank you very much. We're going to be discussing two products this morning. One of them has been around for a long time, and that is the NCHRP 350 product we call the SKT, or the Sequential Kinking Terminal, and we're going to then discuss the current version of that product, which is MASH compliant, and that product is called the MSKT. Both of those systems are currently being used in South Carolina in a test level 2 and a test level 3 configuration. So before we get started, I'd like to establish a couple of the rules as we move forward when it comes to installing and maintaining and designing these products. The first one is to follow the manufacturer's instructions. Rule number 2, do not mix different parts of different products together. And then rule number 3, please follow rules number 1 and 2. If we can get through those two rules, I think we're going to have a high level of success as these products are implemented, installed, in service, and then repaired and maintained as they're being impacted. So the two products that we're going to discuss, the one on the left is the MASH version of the MSKT, and the one on the right is the NCHRP 350 SKT. There are some parts that are interchangeable, they're identical, but there are some differences. You'll hear me discuss a lot of these points throughout the presentation, but just to get started, the primary differences are what you see here on the screen. With the MASH version, the rail height is 31 inches compared to the old 29-inch rail height. The rail splices in the MASH version are mid-span between posts, where the 350 SKT had splices at the post. The block outs are different. We're using a 12-inch block for the MSKT. And the impact head is a little bit different. You can see with the MSKT, it's enclosed on the feeder chute and on the traffic side, and it's open in the older version that's been around since the late 1990s. And then the other thing that you'll see is different is the ground strut. The 350 version of the SKT for this particular model that we call the SKT SP did not use a ground strut, where the MASH version does use a ground strut. So if you didn't catch all that, don't worry. We'll get into all of these things as we progress forward. The MASH MSKT is intended to be used with the current W-beam system called the MGS guardrail, the Midwest guardrail system, and the older NCHRP 350 is intended to be used with the 29-inch strong post W-beam. The 350 system, you'll sometimes see it referred to as the SKT-SP-S-MH, and I'll just be referring to that as the SKT-SP for short. But all those letters, they do mean something. The SP stands for the standard post system, meaning that post number 3 and beyond are standard steel guardrail posts 6 foot long. The -S simply means that it's a steel post system, and the MH means that it's using the MASH head. Now, most of the units that are out there have the older head with the open feeder chute on the traffic side, but moving forward for repairs, the only impact head that we are producing is the MSKT head, and that does have allowance to be used on the older systems as well as the new MASH systems. Looking at the NCHRP 350 repairs, the SKT SP is being used in a test level 3, which is 50 feet long, and a test level 2, which is 25 feet long. Now I'm going to talk a little bit more about the lengths as it relates to the DOT pay limits, but for the purposes of the activation and the amount of rail used during an impact, typically the TL3 is about 50 feet and the TL2 is half of that at 25 feet. The 350 version, as I mentioned earlier, uses the 8-inch composite blocks. No wood blocks are used in South Carolina, and it does have the steel post. Your standard sheet for that version is 805-700-M11. And as we said earlier, that's a 29-inch rail height, plus or minus an inch. It's attached to a strong post W-beam. Moving forward, the only time you're going to use this older 29-inch rail height system is for maintenance or repairs. And you'll see on some of your standard sheets that that may not address the grading or the earthwork, but that is something that needs to be considered as we repair these, and especially when we install the new ones, the MASH version. So this is a quick snapshot of your 805-700-M11 sheet. I realize the print is rather small. You may not be able to read it, but I did want to point out a couple of things that are shown on that drawing. At the top, you can see the pay length is about 54 feet, and that includes a delineator up at the front. 2 feet in front of the impact head, there's a delineator that is included as part of the system on your standard sheets there. And for the test level 2, again, that is half of that up through post number 5. And again, that system uses 8-inch blocks, and the rail splices are at the post. What you see here, this is a road systems drawing. This is our internal drawing, and this simply shows the system with all of the components, and it does have the MASH impact head, the head that has the enclosed feeder chute. So that drawing that we are calling the SKT-SP-S-MH, meaning the steel post system, standard post with the MASH head. Here you can see a comparison of those two impact heads. They weigh about the same, and they function the same. There are a couple of things that are different. You can see the enclosed surface, and we also put the letters SKT in the open, the closed section of the feeder chute. I often get the question, why did you put SKT and not MSKT? Well, our concern was that this impact head could possibly be used on the older 350 systems, and if it had MSKT on it, it may be looked at as a MASH compliant system. So the point here is, by simply putting the MASH head on a 350 system, that does not make it MASH compliant. There are some other things that are different, and we'll talk about those in detail as we move forward. But you can see the differences in the two heads on the photos on the screen there. So this is your SKT SP, your 29-inch system that is in place, and this one shows the older head that has the open feeder chute, as you can see right here. There was some terminals that were used years ago that also had an impact head, but our head is a little bit different. One of the things that is easy to tell it from the others is that it is the longest of all the impact heads that are used. If you look, the end of the feeder chute here extends actually slightly over the cable anchor bracket. That's the only impact head that's currently used in guardrail terminals that has a feeder chute that extends over the cable anchor bracket. This has a center stiffening plate that you can see right here, a deflector plate that allows that rail to be kinked as it's impacted. It is square on the front. It's about 20 inches square on the front. It has an open throat configuration, so when that rail comes out, you'll see later that the rail is not flattened. The corrugations remain in the rail when it's impacted, but there's a series of kinks that are formed, and that's how we name the product, the sequential kinking terminal, the SKT. The cable anchor bracket is unique. All of the hardware in these terminals are able to pass through the impact head. The shoulder bolts that attach the cable anchor bracket, the post bolts, the splice bolts, those can all pass through the impact head, but the cable anchor bracket cannot. So we need to be sure that we have some type of a release mechanism, and the shoulder bolts and the anchor bracket that we use allow that. Another view of the NCHRP 350 29-inch SKT SP. You'll see that both the 350 version and the newer MASH MSKT uses posts that look very similar. At 1 and 2, there is a 5/8-inch bolt on the upstream side at the base of post number 1, and a 3/4-inch bolt on the downstream side at post number 2. That is the same for both the MASH and the 350 version, but there are some slight differences in the posts, and we'll talk about those as we move forward. And again, a couple of more views of the 350 version. Upper post number 1 is a 6-inch by 6-inch square tube, and you can see here that the impact head is firmly bolted to the post. The rail is not bolted to post number 1, but the impact head is. And for this NCHRP 350 SKT, we have a installation manual available for that system, and that installation manual is available for download on our website, www.roadsystems.com. Looking at the MASH installations, this is the MSKT-SP-MGS12. Again, a lot of letters, and I'll just be referring to it as the MSKT. That is available in a test level 3 and a test level 2, and that uses the 12-inch block. That's a composite block, no wood blocks permitted, and it uses a steel post. The SP just simply stands for a standard post system, again, meaning that post numbers 3 through 8 are standard 6-foot-long guardrail post. The MGS means that it is applicable and intended to bolt to your MGS, your Midwest guardrail system, downstream of the terminal, and the 12 means that we're using 12-inch blocks. There are 4 standard sheets in your plans that are used to talk about this product. There's 2 for the test level 3 and 2 for the test level 2. Take a look at those 4 standard sheets. Here is your 805-115-10, and that is your grading details for the new MASH system. And then your dash 11 is the plan and elevation for the new MASH system. And you can see here that there's a length shown as 72 feet, and that is a design length that South Carolina DOT uses for this system. So that distance, as you can see here, has an area in front of the terminal. It has the delineator 2 foot in front of the impact head. There is a non-mow strip nose pad that extends in front of post 1 and beyond post number 3. And you can also see a couple of other dimensions there that refer to what we call the pay length. But from a design perspective, that is your layout for the test level 3. Looking at the test level 2, very similar, except everything is essentially cut in half. Everything in the front is going to be the same, but the downstream 25 feet has been eliminated. And here you can see your grading details on your test level 2, 805-115-50, and then your dash 51 for your test level 2 shows similar characteristics that we saw on the test level 3, your non-mow strip, your delineator, and your design length on the test level 2 being 42 feet. And that extends halfway between posts 6 and 7 on the test level 2. So let's get into the nuts and bolts of the MSKT. This is a MASH terminal. You'll hear me refer to MASH multiple times. MASH is an acronym stands for the Manual for Assessing Safety Hardware. I'll talk a little bit about that, but essentially that's just a document that tells our industry what crash tests need to be conducted and how to evaluate the results of those tests to determine if the product was successfully tested. And this MASH MSKT is intended to be installed at a 31-inch rail height and attached to your 31-inch MGS guardrails. It is very similar, as we've discussed, to the NCHR P350 version. The two side by side you see here, the top one being the MASH version, the bottom one being the 350 version, and we talked about some of those differences. We're missing the strut and some other things that are pretty obvious as you take a quick glance here. What you see here is the NCHR P350 version. The MASH version does use the same end rail, so that is interchangeable. It uses the same cable anchor. Looking at it from the back side, this is the NCHR P350 version, but on the MASH MSKT, we're using the same cable anchor bracket, the same shoulder bolt. So there is a lot of interchangeability between the parts, but I want to be sure that we focus on the things that are different so you understand the things that make the MASH MSKT system unique. Another view of the impact head, and you can see it from the front and the back side. Again, this is the head that's used on all new MASH MSKT installations and all future, effective the beginning of this year, our company stopped making the older version of the impact head, and this impact head is also used on the 350 versions for repairs of systems that are in place. So here's the MASH MSKT system in place. Steel posts all throughout the system. Post numbers 1 and 2 have an upper and lower bolted connection. Post number 3 through 8 are standard 6-foot-long guardrail posts. One of the most important parts of a guardrail terminal, and probably the most common thing that I see wrong with guardrail terminal installations, and I'm not just talking about South Carolina, this is nationwide. You can get on pretty much any highway in America, and you don't have to drive too far before you see a terminal that has bad grading. And you have to remember that these systems were developed, crash tested on a flat and level area that has no obstructions. And of course, we don't have that luxury in the real world. So when we call for a terminal, we need to be sure that we address the grading from the advanced area, the adjacent area, and the runout distance. And this is a detail that's taken right out of the AASHTO Roadside Design Guide. If you look at this system right here, at a glance, it might look like a pretty nice installation, but visualize yourself hitting this head on. You're going to have the 2 tires on the passenger side halfway down the slope. You're going to have the 2 tires on the driver's side up on the grading, and that vehicle is going to be halfway to the point of rolling over. It's going to be very unstable, and impacting the terminal is not going to correct that. So we need to be sure that we install these in an environment that's going to allow them to perform as they were designed and tested. Another thing we need to keep in mind when these systems are installed is we do not want any of the rail within the terminal to have any curved sections or radius within the terminal. We do permit a flare or an offset of up to 2 feet over the 50-foot length. And when I say 50 feet, I'm referring to a distance measured from post 1 to post 9, all 6'3" post spacing. That's a 50-foot distance, and we're allowed to offset post number 1 up to 2 foot relative to the positioning of where post number 9 is, the 50-foot distance. But again, that offset has to be a straight flare, no curved rail in the terminal. 31-inch rail height, plus or minus an inch, and we have an installation manual for this system on our website as well. Here you see the MSKT installed on the left shoulder here. Looking at it from the back side, The rails in the system, as we said earlier, have a mid-span splice. So how do we achieve that? I mentioned earlier that the end rail, that first 12-foot section spanning from post 1 to 3, is the same as we've always used from the beginning. So that rail did not change. So there is a rail splice at post number 3, but beginning at that second rail, we're supplying a 9-foot, 4.5-inch section of rail. And that's an odd length, but what we're doing here is we're establishing the positioning of the mid-span splice that happens halfway between post 4 and 5. And then from that point downstream, we're using all 12.5-foot sections. So we have a 12-foot section on rail section on the end, 9-foot, 4.5 second rail, and then 12-foot 6 rails extending beyond. The major components up around the system that has the unique parts, we'll talk about these going top left, and then we'll go clockwise. The MSKT impact head, and as I said before, the head itself is bolted to post number 1, but the rail is not. That end rail is unique because it has 1/2x4 special slots. There are 3 slots in the valley of the rail at the center line that you see here, and then there's 5 slots on the top corrugation and 5 slots on the bottom corrugation. So this rail is unique because of those 13 1/2x4 slots, and it will also have 8 holes to allow the attachment of the cable anchor bracket and those unique shoulder bolts that allows the bracket to release on an end-on impact. Looking at post number 2, you can see there are open-ended slots, and there's 2 slots. This is a universal upper post number 2. This post number 2 upper is used in both the 350 SKT as well as the MSKT. And the reason for the 2 slots is the upper slot represents a 31-inch rail height, and the lower slot represents your lower 29-inch rail height. So if we're attaching for the MGS, we use the top slot. Attaching for the older system, you'd use that lower slot. Both the 350 and the MASH have the 3/4 bolt that attaches the upper and lower post number 2, and that bolt is on the downstream side. There is a ground strut that's used. That ground strut is not symmetrical. There is a longer section that spans over post number 2 because the attachment is on the downstream side. The shorter section of that ground strut is on the attachment to post number 1, and because that bolt here that attaches the ground strut to lower post number 1 is on the downstream side. So we have a strut that has a longer yoke area at post 2 than it does at post 1. There is 2 bolts, 5/8, at the base of post number 1, the 1 bolt to attach the ground strut, and then the 1 bolt on the upstream side that attaches upper and lower post number 1. That bearing plate is 8 inches square, but the hole in the plate is not symmetrical when properly positioned. The bearing plate would be resting, as you see here, with a 5-inch dimension up and a 3-inch dimension down. And to maintain the correct positioning of the bearing plate, we use a retainer tie, as you see here. So those are the components that make this system unique, and we'll talk about some of those a little bit more as we move forward. The one thing that you'll see with the upper post number 1 for the MSKT that we did not see on the 350 SKT is this spacer. I'll show you another view of that, but what that does is it positions the bearing plate at a negative angle, and it helps towards our anchor load for the traffic face impact condition. We do put a little bit of information on that impact head for our internal information. There's a product ID plate that has some information that helps us if we ever need to track down lot numbers and production plants and such. Here you see your what I'll call the 50-foot system, your impact head, your posts 1 through 8, your standard post beginning at post 3 to number 8, 12-inch plastic blocks. And there's a point within the terminal that we refer to as the length of need, the beginning length of need, or the BLON. And that point is post number 3. And if there's any designers out here listening, what that means is that the terminal does have redirectional capabilities at and downstream of the 3rd post. And we'll show you the test that we conducted to demonstrate that. Taking a closer look at upper and lower post numbers 1 and 2. I mentioned earlier that upper post number 2 is the same in the 350 version of the SKT, but the MSKT lower post number 2 is longer. There's a soil plate on the downstream side of lower post number 1. Lower post number 1 is similar in the MSKT and the older 350 SKT version, but there are some slight differences. One of them, we needed to extend the side plate so we could attach the ground strut. Remember, the 350 version did not use a ground strut. Here you see lower post number 1 with the soil plate that would be on the downstream side, and those side plates. You can see there's 2 holes in the side plates, one for the ground strut and one to bolt the upper post to the lower post. I'll caution you, do not cut lower post number 1. It does have a 6-foot embedment. Both 1 and 2 have a 6-foot embedment. Now we do have some accommodations to install these if you do happen to hit solid rock. We do have instructions that we can provide to show what to do and when to cut the post, but you never simply cut the post and just install it as you normally would. The other option that we have if you hit solid rock is to cut the posts and put a concrete foundation. But if there's ever a situation where we need further explanation on that, just give us a call and we'll be happy to provide you the details to accommodate rock if you do hit it. The upper post number 1, I mentioned earlier that there's a spacer angle welded to it. That would be an indication that that is the MASH upper post number 1. The 350 upper post number 1 did not have that spacer angle. If there's any installers out here listening, I will caution you that we do not want to pound or put the load on the side plates when we're installing these. There's a possibility of damaging the plates or damaging the welds. All of that load should be applied to the top of the post itself, not to the side plates. We do recommend that the contractors that are installing these develop some type of a driving cap. This is just one example of what one might look like. We don't design these caps. We don't supply these caps. Those would be built for the contractor based on the equipment that they have and their needs in the field. This is one of my how not to slides. This is post number 2. This is lower post number 2 that is being driven with all of the load being applied to the side plates. Again, we never pound on the side plates themselves. We could possibly damage the plates or damage the welds. So there should be a driving cap as well developed for post number 2. We also never want to install the upper and lower post 2 while they're bolted together. And this is another one of my how not to slides. You can see here the contractor is pounding post 2 upper and lower while it's bolted. We could possibly damage the bolt. I'll also mention, if you look in the background there, this is done under a controlled environment, so we intentionally did this just to show how not to. This is an example of what a driving cap might look like to drive post number 2. And this is the correct installation of post number 2. You can see here that all of that load is being applied to the top of the post itself, not to the side plates. Looking down at the base of post number 1, the components that I talked about earlier, you can see the 5/8 by 9 hex bolt. There's 2 of them, one to attach the ground strut, one to attach upper and lower posts. Number 1, you can see the spacer. And you can also see the retainer tie to help keep that bearing plate in its proper orientation. Looking at post number 2 attachment, we pointed out earlier that those open-ended slots would be facing towards post number 1, and that 3/4 bolt is on the downstream side. So on an end-on impact, the impact head is going to be sliding down the rail, and when post number 2 is activated, it will hinge at the lower bolt on the downstream side, and upper post number 2 can release from the rail without tearing any metal. It should be able to pull out of that open-ended slot. Looking down at the bases of post number 1 and 2, you can see your ground strut with the shorter tabs attaching to post number 1. And there's that 3/4 bolt on the downstream side. You can see there's no washers used on that bolt at post number 2. We tested it without washers, but if washers are supplied and or used, that is not a problem. Here's the connection at upper post number 2, and again, those open-ended slots are facing towards post number 1, so when it's activated, the rail can release from the post without tearing any metal, and sometimes we'll see that upper post number 2 can be reused. We want to be sure that the bolt that we use to connect post number 2 to the rail is a short bolt, as you see here, and not a long bolt that would extend through the back side of the post, creating a possible snag point when the impact head is trying to release the rail from the post. So want to be sure that we use the proper bolt at the connection at post number 2. And the upper slot is used for the 31-inch MSKT installation. This is an MSKT that was impacted, and you can see here how post number 2 has rotated. It pulled out of the connection at post 2 to the rail. Post number 1, remember that 5/8 bolt is on the upstream side, so that 6-inch by 6-inch tube that represents post number 1 is actually torn away. So post number 1 would not be reused because the connection is on the upstream side. Post number 2, the connection is on the downstream side. This is that product identification plate that I mentioned at post number 1. And again, the head is attached to post number 1, but the rail is not. We use a couple of 5/16 by 1 hex bolts to attach the head to the post. The cable anchor bracket, this is the same one that we have used since the SKT was introduced in 1997. It has special shoulder bolts, and you can see there's a washer that's installed on both the sides of the rail. This is actually, the washer here is what we call a captive washer. When this bolt is shipped, the washer is permanently attached to the bolt so that we be sure that we can get a washer on both sides of the rail. Again, those rail shoulder bolts will remain in place. When the bracket is kicked away, the bolts will feed right through the impact head. Now this is my SKT impact head. This is not the SKT rail, and this is not the SKT bracket. There's no slots, and you can see that that bracket is solid bolted to the rail. That's the problem. Here's another view looking at the back side. Again, this is the wrong bracket. When the impact head travels down the rail and attempts to release the head from, release the bracket from the rail, you can see here that it would dig into the bracket and bring your impacting vehicle to a screeching halt. So this is a problem. We need to be sure that we're using the proper shoulder bolts and the proper cable anchor bracket. What you see here is, gentlemen, is securing the cable as he's tightening the nut on the end of the anchor cable. What he's doing here, he's preventing that cable from winding up. If he were not to secure the cable, there would be the possibility of that cable twisting or winding up as the nut is tightened, and then you walk away, and over time it's going to unwind and the cable's going to go slack. We want to be sure that we use the delineation that is placed on the front of the terminal. I know that DOT is looking into some further guidance on delineation, both on the impact head of the terminal as well as the guardrail itself. So stay tuned for further developments on that. And of course, we need to be sure that we have a clean, dry surface, or you're going to get something like you see on the left here over time. And of course, we need to avoid that. Inspection. Once these things are properly installed, they do need to be inspected. South Carolina DOT does have a document. It's a couple of years old, but this currently only talks about the W-beam guardrail, the cable, and some attenuators. The terminals are not really well represented in here, but that may get updated down the road as you get a little bit more experience with the system. In our installation manual, we do have an inspection checklist, and we would strongly recommend that this be used both during the initial installation, especially if we have a contractor that's not familiar with it. It could be used for inspection by the DOT before the system is approved and paid for, and would also be used after maintenance to be sure that we've got everything correctly in place. And what you see here is just a visual of what you saw on the previous slide here, the inspection checklist. So some of the things that we're looking for, we need to be sure that we have all the proper rails that are in place, the posts are all spaced correctly with the 12-inch composite blots. We have the proper end rail. The impact head is placed parallel on the rail so that it's not leaning up or down. There's no post bolt connecting the rail to the post at post 1. The stub height, as posts 1 and 2 are fractured, we want to try to be sure to keep that to no more than 4 inches. We have our proper shoulder bolts. The rails are bolted properly at 1 and 2 at the rail to post connection, as well as the ground connection. And again, there is no rail to post connection at post number 1. Let's talk a little bit about the crash testing. I mentioned MASH, I mentioned NCHRP 350. Again, those are documents that tell the industry what vehicles to use, what tests to conduct, and how to evaluate the results of the tests to determine if the test was successful. It strictly addresses the test and does not address the installation or the application. So on the older 350, we used a small car that weighed about 1,800 pounds. That's now increased by 600 pounds to 2,400 pounds. And the pickup truck also has increased by 600 pounds as we move to the new MASH criteria. This is one of the reasons that the testing standards were updated, because the vehicles that the automotive industry is producing and America is buying and driving have increased in weight. So we want to be sure that we are putting products out there that can accommodate the vehicles that are being used throughout America. What you see here is the test matrix that the MSKT was subjected to. There are 4 tests with a pickup truck and 3 tests with a small car. Tests 30 and 31 are both end-on impacts, and with the small car, the vehicle is off-center. The pickup truck test, test 31, the vehicle is centered, and that's what we call the capacity test. We want to see how much rail is consumed when a 5,000-pound pickup truck impacts the end of the terminal at 100 kilometers an hour, or roughly 62 miles an hour. MASH is a metric document. That's why you see nice round metric numbers. Test 32 and 33 are impacts on the nose at an angle. There's an asterisk there showing that these are significant changes. Under 350, those tests were at 15 degrees, and with a higher angle, the vehicles would really just sail right through. These are gating terminals, meaning if you hit it on the nose at an angle, the vehicle will gate through or pass through. But with MASH, we reduced that so that we're having the vehicle interacting with the end terminal longer because of the shallow angle, and we're really challenging these terminals to do more with the MASH testing. Test 34 and 35 are traffic face impacts, the small car at 15 degrees at what's referred to as a critical impact point, and then test number 35 at that BLON point, or the beginning length and need point, at 25 degrees. And that's the test that we use to demonstrate that these terminals have redirective capabilities at or downstream of the third post. And then test 37, that test is a reverse angle. Sometimes these terminals are installed at locations where you have two-way traffic and there's a possibility of the terminal being impacted from the reverse direction, and we need to test that. So in the older MASH, we used a pickup truck. MASH was actually revised in 2016, and that was changed. So we actually ran both tests with a pickup truck and a small car on the reverse direction. So on an end-on hit, there's 5 things that are going to happen. First of all, keep in mind that a terminal needs to do 2 things. It needs to render the end of the barrier safe when impacted end-on. And we showed you the 2 tests that we used to demonstrate that. But also, the terminal does need to provide anchorage on that test 335. And during that test is when we're loading the cable and putting that anchor really to the test. On an end-on hit, there's 5 things that are going to happen. We have an impact head that weighs about 170 pounds, and you have to accelerate the impact head to the same speed as the impacting vehicle. So we have to begin to accelerate the impact head. We have to release the connection of the head to the post. We have to fracture post 1. We'll begin to deform the rail, begin that kinking process, and then that impact head travels down a little bit, and then we're going to release the cable anchor bracket. So those 5 things are going to happen literally instantaneously. It's pretty much as quick as you can blink your eyes. Those 5 things are going to happen on an end-on impact. Back to the length and need point, the traffic face impact. What we're ensuring is that if the terminal is impacted at or downstream of the third post with a 5,000-pound vehicle at 25 degrees, that vehicle will be contained and redirected. And what you're seeing here is the load that's being applied to the terminal during that test. Now remember, we increased the weight of the vehicle by 600 pounds. We also increased the angle. So we're putting considerably more load on MASH terminals during the testing than we did on the 350 vehicles. You can see here the load that's applied as that 5,000-pound pickup truck is captured, contained, and redirected. On an end-on hit, this is the capacity test, and this is that same 5,000-pound pickup truck, also at 100 kilometers or 62 miles an hour, but this is at 0 degrees, and we're trying to establish the capacity of how much rail is going to be consumed on this type of a design impact. And it turns out that it takes about 50 feet to bring that vehicle to a controlled stop. This all happens within about a second and a half. What you see here are the frames and the time that are moving. So time is stopped here at 1.5 seconds, and we're running about 1,000 frames per second on this high-speed video. And so we ran through about 1,500 frames on 1,500 milliseconds, bringing that vehicle to a controlled stop. You can see not a whole lot of damage to that pickup truck considering the severity of the impact. And what that clearly tells us is most of that energy was absorbed by the deformation of that kinked rail that you see there, and not so much the loads that were applied to the vehicle. And this is what it looked like after impact. There's our MSKT in place. System's been out on the road about 2.5 years now. Mid-2016, we received our FHWA letter, and tens of thousands of them all throughout the country. They are getting hit. We are gathering some good data, and they are performing quite well for us. But when they are impacted, they do need to be repaired. And what we're recommending is keeping all the rail on the downstream side attached and in place, we would cut the kinked rail as close to the exit slot of the impact head that we could. And because of that open throat area, you should be able to remove that impact head from the rail without too much difficulty. But if there's some additional damage or there is difficulty getting it off, you can always just hook a chain around it and pull it off that way. I want to spend a couple of minutes here talking about some online training that we released earlier this year. This is on our website. If you go to www.roadsystems.com, throughout the site, including the homepage, are links for the MSKT online training. Or you could go directly to it by going to the address that you see there on the screen. There are 6 lessons in this online training. The first 4 are providing a lot of background information. Lesson number 5, you actually install the system on the screen, and then lesson 6, you can take a test. Some of the features of this training, there's 3D views of the system that you see here in its assembled configuration. You can explode it and take all those parts and look at them individually. You can rotate that assembly in any position that you care to view it. And then the portion of the training in lesson 5 where you actually install it. You build it on the screen. And what you see here, this would be your starting point when you started the beginning of lesson 5. You can see here, you start at post number 2, and there's a directory of parts, of components down below that you choose from. So what you would do here is you would click post number 2. You don't drag and drop. You just click it. Click post number 2 from the list of parts below. Then you click on the screen where it belongs. And if you select correctly, it'll be in place. If you select wrong, it will give you feedback that that's not where it belongs. And here you can see the installation process has progressed, where upper and lower post number 2 are in place. The circles that you see there are targets to help you choose or give you some clues of where that part goes. And once the part is correctly selected, it shows up in the directory at the bottom as checked. So you can see here, upper and lower post number 2 have already been selected, and they're checked as being marked off. Here now, the rail and the ground strut have been selected and marked off, and those are shown as being checked. And here at this point within the selection, there's only 2 parts that need to be installed. Everything else has been accounted for. We need to install the 3/4 bolt at the downstream side of post number 2 and the 5/8 bolts at the upstream and downstream of post number 1 for the strut connection and the upper-lower connection. Some of these parts can be installed in any order, but of course you can't install a bolt to attach lower post number 2, for example, if upper post number 2 is not in place. So there's a lot of design that went into this to be sure that we install the parts where they belong and to some extent in the correct order. And then once your system is completely installed, your directory at the bottom now has changed colors. It's checked where everything now is correctly installed. And once you complete lesson 5 and install it, you can then move on to lesson 6, where you take the exam. And if you score correctly, 80% or better, you can print out a certificate that shows that you have completed the online training. Moving on to the final portion of the webinar here, we're going to talk about proper installation, application, and maintenance. I mean, let's be realistic here. You could have the best product that was ever developed, best product that was ever tested. If you install it wrong, if you put it in an environment where it wasn't intended, the way it was not designed and tested, all bets are off. The system will not perform as designed unless it's properly applied, properly installed, properly maintained, if it's been damaged. A term that's been used in the industry here for some time is Frankenstein terminals. And what we mean by that is we're taking parts of one terminal and combining it with another. What you see here is the SKT impact head, but it's attached to a rail and an anchor bracket from another product. And that, of course, is a problem. This is another example interchanging the parts of those same two products, but this time it's somebody else's impact head on my rail and my cable anchor bracket. So if it can go wrong, it will. These are things that should have been detected during the installation or during the maintenance if this was a repaired unit. So this is a picture that somebody sent to me looking at the anchor bracket and the rail. That's clearly the rail and the bracket that belong to the SKT or the MSKT, but what impact head did they put on it? They put a buffered end. So again, if it can go wrong, it will. We need to pay close attention to the way these things are installed and maintained. This is a wood post system that uses foundation tubes. I know that wood posts are not being used in South Carolina, but it certainly shows the example of bad grading. If you were to impact that head on, you would have the foundation tubes tearing out your gas tank and everything else, and that can present some very, very serious problems. Here's another example of bad grading. This is the SKT. And when we have a situation like this, the first thing you want to do is try to adjust the grading. But if you can't adjust the grading, the other thing you can do is extend the length of the rail, possibly forward, so that you can avoid placing the terminal in an environment like you see here. This is an SKT being used on a left shoulder, but the problem is it's actually in a median. And we have a roadside terminal being used in a median. We can't expect it to perform as designed. And also you can see that the rail is very, very low. This one is going to be a problem if it were ever impacted. There's nothing right about this installation, whether it be a traffic phase impact or whether it be an end-on impact. We can't expect this terminal to perform the way it was designed. And I think you can clearly see some of the problems that you have here. And if you look closely, there's not even any guardrail on the downstream side. It's simply a terminal that's just in place with nothing attached on the downstream side. I'm not aware of any crash-worthy fire hydrants, so I would not sign off on this application. Here we have a terminal that may perform quite well up until we get to about 8 or 9 feet. And somebody may say, well, hold on a minute, John. Take a look at that pole a little bit closer. That's a crash-worthy pole with a frangible base. For the sake of discussion, let's assume that it is. But I can assure you that the pole was not designed in conjunction with a terminal, nor was the terminal designed to function with a breakaway pole halfway through the stroke length. So although we may have two crash-worthy systems in conjunction with one another, we have a problem. We never want to see any of the rail peeking out through the impact head. With our MSKT, with the enclosed feeder chute, that's one of the things that we ensure would not happen with that system. We should never see any air, any space between the end of the rail and the throat of the impact head. Mentioned earlier that we never want to see any curved rail within the installation of the terminal. Keep in mind that the impact head is being pushed down the rail by the vehicle, and we're depending on that straight rail, the column strength of that straight downstream rail to provide the resistance to allow that head to track down the rail. You put a curve in there, and you're introducing premature buckling, and the system is not going to perform as was designed. We're missing a bearing plate. So on a traffic phase impact, we're not going to have any anchorage, and we have a post attaching the rail to the post at post number 1, which is going to be a problem for an end-on impact. So At 60 miles an hour driving down, you might look at this terminal and say, yeah, it looks pretty good. Upon further inspection, we would not expect this to perform well in an end-on hit nor a traffic face impact. Here's another thing to watch out for, your bearing plate. You don't want it to be buried. Now, this one's not real bad. I've seen worse where they're buried even further in concrete. When the impact fractures post number 1, the first thing that should happen is you should release the tension on the cable and allow the impact head to travel down and kick that cable anchor bracket off. If that bearing plate is buried and locked up, a snag point at the base of post number 1, the impact head's going to get to the anchor bracket, try to release the cable, and it's going to still be secured at the base of post number 1. So what we see here is a problem. On an end-on hit, we would have that other rail probably going right in through the engine compartment, possibly through the into the vehicle. That's a problem. I don't know how we could ever expect this terminal to be properly activated. Some of these pictures you just look at and you ask yourself, how did it get to that point? On a traffic face impact, we might be okay here, but on an end-on impact, I think you could see that your vehicle would be caught up in something that's not going to allow the terminal to perform as designed. Just way too busy here, too much going on. If there's even a possibility that this terminal could be impacted and begin to slide that impact head down the rail, we have this pedestrian rail up at the top that's going to be going right through the windshield. So, you know, designers need to understand the way that these things are designed and put them in environments that will allow them to perform as they were intended. The maintenance we see oftentimes is where some of these things go wrong. Rather creative, but I don't like it, not one bit. Here we can see two problems. The bearing plate is missing. The anchor cable is not attached, and we have that long post bolt that we cautioned against attaching the rail at post number 2. Again, a wood post system not used in South Carolina, but I guess another example, if it can go wrong, it will. They put the post in upside down. You can see our bearing plate is halfway up the post. Special delivery, I think not. And again, just one more plug for the online training. And with that, I thank each and every one of you for your time this morning.